All right, boys and girls. Today we're dealing with types of angles. And we're looking at adjacent angles first. In previous lesson we learned that B is the vertex. All right, the point where all three of those rays are being drawn from. Now if you look clearly at this diagram, you will notice that two angles have been formed, B1 and B2. Now, we must make mention that B1 and B2 are known as adjacent angles because they share a common vertex, B, and they share a common arm, BC. They also lie on either side of BC. And that's what makes them adjacent angles. Complementary angles are angles that add up to 90 degrees. So if I have a drawing like this, you'll notice that I have a 90-degree angle drawn, and that 90-degree angle is divided into X and into Y. This means that X and Y are complementary angles because if I add X plus Y, I should get an answer of 90 degrees. Supplementary angles are angles that add up to 180 degrees. If you look at my diagram, I have a straight line drawn and we have A and B, angle A and B. In supplementary angles, A plus the B will give you 180 degrees. They are supplementary angles. Or you can also mention them as angles on a straight line. Lastly, we are looking at angles around a point. And if you look at this last diagram, angles around a point add up to 360 degrees. Because if you look, they have a common point, but it's almost like they are in a revolution. So what I mean is that angle R plus X plus Y plus Z is equal to 360 degrees. Now I have done some examples and we're going to go through them with you. I'm going through them with you. We have a diagram, and in this diagram we notice that there is a 90-degree angle. This 90-degree angle is divided into X plus 20 and the angle X. When we are busy with geometry, we always have a statement and a reason. Looking at the statement and reason, under my statement, I am going to write down an equation. I know that X plus 20 plus X, this X, would be equal to 90 degrees. And my reason I write is they are adjacent complementary angles. Now, like an equation, I need to add the like terms. And so I have 1x plus 1x, which then gives me 2x, plus my 20 degrees, which is 90 degrees, which is equal to 90 degrees. Now, I need to transpose. I need to take over my 20 degrees. And when I do that, the sign changes to minus 20. So I have in this last step 2x equals to 90 minus 20 degrees. My next step is 2x equals to 90 minus 20 degrees is 70 degrees. Now to solve for x, I do not want 2x, but I need 1x, and so I am going to divide both sides by the coefficient of x, which is 2 in this case. 2x divided by 2 is equal to 70 divided by 2. 2x divided by 2 is equal to 1x, which is equal to 70 divided by 2 is 35 degrees. And that is your answer for number 1. The next kind of example is, can you see? Right, there's a straight line and we have rays coming from a common vertex. And we have three different angles that are formed. There's a 30-degree angle, 80, 2x minus 20 degrees. And now, because they're angles on a straight line, under our statement, it's going to be our 30, right, plus 80 plus 2x minus the 20 degrees equals to 180 degrees. All I'm doing is adding each of these angles and making them into an equation where they equal to 180 degrees. My reason is adjacent supplementary angles. Or you can also say angles on a straight line. But for this now, we need to now add our like terms. There's no 2x on the left-hand side, so it remains 2x. But let's look at what happens to the angles. 30 degrees plus 80 is 110 degrees. 110 degrees minus 20 degrees is 90 degrees, which is equal to 180 degrees. Our next step is to separate the x's from the constants, which in this case are the angles. So my 2x remains on the left-hand side, which is equal to my 180 degrees, which is positive. But look what happens to the 90. When I transpose it, it becomes minus 90 degrees. So in that line, it reads 2x equals to 180 degrees minus 90 degrees. 2x equals to 180 minus 90 is 90 degrees. I am solving for x, therefore I need to divide both sides by 2 because I want 1x. 2x divided by 2 is 1x. 90 divided by 2 is 45 degrees. I'm sure you think this is rather easy by now. So let's go on to our last example, which is, we have a little drawing there. 150 degrees, x 40 degrees, and we have this angle being a 90-degree angle. If you look at this angle, it's almost like if I had to start from that point going right around and returning, it would give me a revolution. Yes, and that's why when we add each of these angles, our answer should be equal to 360 degrees. Our reason, angles around a point. X, right? My next step, plus 150 plus 90 is 240 degrees. Plus 40 gives me that 280 degrees, which is equal to 360 degrees. Again, with the equations, we're separating the unknowns from the constants. My x, I'm leaving on the left-hand side, equals to, my 360 is positive on the right-hand side, so it remains like that. But my positive 280, when I transpose it, it becomes negative 280. Let's look at our final answer. X equals to 360 minus 280 gives me an answer of 80 degrees. That is my final answer.